this video, M&W Instruments, a daughter company of Bronkhorst High Tech, the market leader in the field of thermal mass flow meters and controllers, presents the operation of the Mass Stream series of thermal mass flow controllers employing the direct through-flow measurement technique. This thermal MFC is supplied with 15 to 24 VDC. After power-up, the LEDs on top of the instrument display its status. When the green LED lights up, the instrument is ready for use. Under the cover of the Mass Stream MFC is the electronics board using surface mount device technology. The measuring part of the instrument consists of a flow straightener element combined with the thermal inline mass flow sensor. Once the instrument has been connected to the process line, the pre-pressure can be set. The body is now filled with gas. The flow sensor consists of two stainless steel pins encasing the heater in the first probe and the temperature sensor in the second probe. A constant temperature difference, or delta T, is created between the two sensor probes. Since the control valve is still in the closed position, the measured value corresponds with zero flow. This signal is forwarded to the microprocessor. The instrument receives a set point via the PC, PLC or analog port. This required value is compared with the measured value. If the required value is higher than the measured value, the PID controller will actuate the control valve. The electromagnetic coil exerts a force on the magnetic plunger holder. This force is in balance with the linear spring that normally keeps the control valve closed. When the plunger comes free of the orifice, the result is a flow through the instrument. The flowing gas cools the heater probe, and the comparator registers that the temperature difference between the two probes decreased. More energy is applied to the heater probe to maintain the desired constant temperature difference. This increase in heater energy is directly proportional to the mass flow as originally set out in King's law. The higher the flow, the more heater energy is needed. The signal from the sensor is compared with the desired value in the microprocessor. The electric current of the coil is adjusted so that the distance between the plunger and the orifice is exactly right for controlling the desired quantity of gas. The control circuit performs this operation in a few milliseconds. In this way, a very constant and stable flow of gas is achieved. One Mass Stream key element is the optional integrated multifunctional and multicolor display with operator buttons on the instrument. The modern-looking display has multiple functions, such as actual flow indication, totalization and alarms, and it is fully IP65 compliant. Proudly presents the principle of operation of their new ultrasonic flow meters and controllers from the S-Flow series. Bronkhorst developed these revolutionary instruments using ultrasonic wave technology to accurately measure liquid flow rates as small as 4 to 1500 milliliters per minute. The unique ability to determine the actual speed of sound of the measured liquid makes the S-Flow independent of liquid properties and very easy to use. The technology can even be used for liquids with changing compositions, dissolved gases or carried particles, without special calibration or complex parameter assignment. S-Flow liquid flow meters have a robust IP67 protected housing, containing an integrated TFT display for readout of the actual flow, totalized flow and alarms, and a capacitive touchscreen for local operation of the instrument. Additionally, the instrument can also be operated via analog, RS-232 or field bus communication. Measuring is done in a straight stainless steel tube with a very small inner diameter. At the outer surface of the sensor tube, multiple transducer discs are located, which create ultrasonic waves by radial oscillation. Every transducer can send and receive these high-frequency waves. Therefore, all up- and downstream combinations are recorded and processed. By using the determined speed of sound and the calculated flow velocity in combination with the exact cross-section of the tube, the S-flow is able to measure volume flow. This measuring principle is highly accurate, very fast, insensitive to vibrations, and, as mentioned before, independent of liquid properties such as density or viscosity. For liquid flow control, Bronkhorst combines the S-flow with a close-coupled pump at the inlet of the flow meter. Upon set point change, the integrated PID controller adjusts the speed of the pump in order to set the flow to the required value. Alternatively, the S-flow flow meter can be combined with a control valve to constitute a compact control loop. Upon receipt of the new set point value, the PID controller changes the current of the electromagnetic coil of the control valve, followed by instant adjustment of the liquid flow. The S-flow may also be equipped with flanged connections. Due to the combination of a straight sensor tube with zero dead volume, self-drainability, and orbital welded tri-clamp connections, this flow meter can be used for hygienic applications in, for instance, food, beverage, and pharmaceutical manufacturing processes. Bronkhorst would be happy to